Hello everyone, welcome back to Lab Leaders Edge. In our last episode, we covered the fundamentals of lab leadership, which included 3 important strategies to become a better lab leader. We touched on everything from establishing standard operating procedures to leverage LIMS software to streamline lab operations. We also explored educational resources for professionals working in biobanks, histopathology, and research labs. Today we are diving into a topic specifically tailored for biobank professionals. We are going to talk about how you can use barcode technology to improve your biobank operations. I'm excited to have here today with us John Wagner. John is an expert in barcode technology and sample management. John will share with us his insights on how barcode technology can enhance biobank operations. John, welcome to the show. Before we dive into technical aspects, could you please share your background and expertise in barcode technology and sample identification?
Thank you, George. Great to be on your podcast. My name is John Wagner. I've spent over 30 years in medical research labs, both as a research scientist and as a lab manager. Over those years, I've seen how researchers have struggled with finding the right solution to identify and track their biological samples. Now, as a product manager, I see a whole new world of possibilities in how we can identify samples more efficiently and accurately. We've developed advanced materials that ensure sample vials remain securely labeled even in extreme conditions, including cryogenic storage, where traditional labels fail to hold up. I've also worked extensively with advanced identification technologies like barcoding. The same technology used to track consumer goods at retail stores can be used to track biological samples in the laboratory. And finally, I've seen how RFID technology can take sample management and identification to a whole new level. Even though many major biobanks have adopted these technologies, one of the most satisfying aspects of my job is presenting these technologies to newer and smaller labs, like academic research labs. Many labs believe that advanced identification technologies are out of reach. I'm glad to show them that these aren't limited to large, well-funded institutions. They are practical, accessible, and have the potential to transform the operations of smaller labs as well. Once smaller labs understand the benefits these technologies bring to their workflow, it's only a matter of time before they adopt them to run their day-to-day operations as efficiently as major biobanks.
Thanks, John. As you know, biobanks are responsible for collecting and storing a large number of valuable biospecimens. But that kind of responsibility comes with some major challenges, especially around traceability and the chain of custody of samples. Could you walk us through some of the challenges biobanks face and how barcoding can help solve them?
Sure, George. When it comes to challenges, manual searching of samples is a major challenge biobanks face. Manual searching is time-consuming and leads to sample identification errors. And these errors are very costly. They can significantly impact research outcomes and even patient care. Losing track of samples can also harm a biobank's reputation and finances. For instance, one location of a U.S. Army medical research facility lost track of some of its important samples for 4 months. They were only able to recover after staff concluded a full inventory of 70,000 vials across 300 freezers. That's where barcode technology becomes a game changer. By assigning each sample a unique identifier, barcoding ensures complete visibility and accurate sample tracking across the entire lab or a biobank. It further improves lab efficiency and also ensures regulatory compliance.
You are right, John. Even small mix-ups in sample identification can compromise the integrity of the results and could even derail the entire research project. One other challenge many biobanks face is in labeling samples that are already frozen. Many biobanks want to implement barcoding but their large inventories of already frozen vials often hold them back because they don't have a solution to relabel them. From your experience, how can biobanks label cryogenically frozen samples?
That's a good question. Labeling legacy vials that are already frozen is always challenging because, in most cases, you can't thaw the samples before labeling them, as you risk damaging their quality and integrity. And most cryogenic labels don't stick to frozen vials. I'm proud to have been part of an R&D program where we developed a labeling solution specifically designed for frozen vials. These labels can be applied directly onto frozen vials or containers. The obvious benefit is that you don't have to thaw your vials to label them, thus preserving the biological integrity of your samples.
Often people don't realize how challenging it is to relabel already frozen vials. Standard cryogenic labels usually don't work on frozen vials. The frost and the low surface temperature make it almost impossible for adhesives to bond properly. Labels for frozen vials require specialized adhesives that can instantly stick to frozen surfaces and stay firmly attached when put back into cryostorage. For years, many biobanks have struggled with finding the right solution for labeling frozen vials. And that's exactly why we developed our CryoSTUCK labels. They are designed to instantly stick to frozen vials and stay intact in cryogenic storage. With CryoSTUCK, it has become much easier for biobanks with a large number of frozen samples to adopt barcode technology. John, from your perspective, how are biobanks currently using barcoding, and what are the improvements and benefits they are seeing from it?
Biobanks today rely heavily on barcode technology, and for good reason. It enhances accuracy in labeling and data entry. By automating data capture, lab workflows run more smoothly, errors are reduced, and researchers save valuable time. It also makes inventory management a whole lot manageable. When every vial or sample has a barcode, you can pull it up instantly in the system. So if you need to find a specific sample in a freezer with thousands of vials, you know exactly where it is and it can be retrieved within a few seconds, instead of spending hours searching through boxes. Another major advantage is maintaining the regulatory compliance. With barcodes, biobanks can maintain a complete and traceable chain of custody, which is critical for regulatory audits and quality control. In my experience, many biobanks across North America, Europe, Asia, and the Middle East have implemented barcoding to transform how they manage their samples. Take the UK Biobank, for example. They use barcodes to track samples all the way from arrival through testing, ensuring that nothing gets lost in the process. And in Japan, the Tohoku Medical Mega Biobank manages millions of biospecimens the same way and integrates barcodes across every step of their operations. Many biobanks are now pairing barcoding with LIMS software, which connects directly to lab instruments like barcode readers, automated liquid handlers, DNA extraction units, and even liquid nitrogen storage systems. That integration really elevates how efficiently a biobank can run day-to-day operations.
That's a great breakdown, John. It's clear that barcoding not only improves sample accuracy, but also makes day-to-day work more organized and efficient. But I know a question that often comes up is the cost. With budgets being so tight, especially in academia and smaller labs, they often wonder if implementing barcoding is really affordable. From your experience, is implementing barcode technology a cost-effective solution for biobanks?
Absolutely, George. But before we jump straight into cost, I think it's important to look at the real advantages biobanks gain when they switch to barcoding. First of all, it cuts down on sample errors. As you know, mistakes in sample labeling can be extremely costly, not just financially, but also in terms of lost research value and reputation. Barcoding takes away a lot of that risk. It also makes labs run faster. Lab workflows become more efficient, and on top of that, the data that you capture is more accurate, which leads to a stronger, more reliable research findings. Another benefit people don't always think about is the amount of information you can encode. Barcode can hold a lot more data than a traditional handwritten or even a basic printed label. And when you connect those barcodes with LIMS or another lab platform, the whole system works together seamlessly. Now, in terms of cost, the entry point isn't as high as people imagine. A basic setup, printer, scanner, software, and labels can come under $1,000. Of course, there's an upfront cost, but the long-term benefits far outweigh the initial investment. So in my view, yes, it's a very cost-effective solution for biobanks.
It's great to hear that the upfront costs aren't really a barrier, especially considering the long-term benefits barcode technology brings. But as biobanks grow and scale, they face another challenge, which is managing large amounts of data. Barcoding solves the tracking problem, but keeping that information organized, searchable, and connected across the lab is a big task in itself. That naturally brings us to LIMS, or Laboratory Information Management Systems. Now my question is, do all biobanks need a LIMS? And what kind of benefits does implementing a LIMS bring to a biobank?
That's a great question, George. Not every biobank starts out with a LIMS, especially smaller ones. But as the number of samples increases, it becomes a necessity. Managing thousands or millions of vials with spreadsheets or paper records just isn't practical. A LIMS really changes that. It centralizes all your sample data into one place, and it ties directly to the barcodes you apply to your samples. Every sample is traceable through its entire life cycle, from collection to disposal. And on top of that, a LIMS helps automate key tasks like data entry, chain of custody tracking and reporting. It can even integrate with lab instruments such as barcode scanners, automated liquid handlers, or liquid nitrogen storage. That level of connectivity reduces errors and saves a huge amount of time. From my experience, biobanks that adopt a LIMS see much better, smoother workflows, better compliance with regulatory requirements, and more reliable data overall.
I agree with you, John. LIMS really adds value, especially when biobanks begin to scale. We'll be covering LIMS in more detail in an upcoming episode of Lab Leaders Edge. John, it was a pleasure having you on the show today, and thank you so much for sharing your insights. In the next episode, we'll dive deeper into barcode implementation, including how to choose the right barcode technology, how to implement it, and address potential challenges. And to everyone watching, thank you for tuning in. If you have any suggestions or you'd like us to cover a specific topic, feel free to reach out to me or John on LinkedIn. We'll see you in the next episode.